year, 1.2 million people are killed on our roadways, and yet the roadway network is the only engineered system where we blame the user rather than the designer when people are hurt. That's not to say that we as engineers aren't doing anything to try to improve the situation. You know, as engineers, we're data people. So we wait for a statistically significant number of people to die, and then we decide to take action. So clearly there's a problem here. Rather than waiting for people to get hurt, what if we used something else that gave us an idea about these crashes before anyone gets hurt? And that's why we use near misses. So to get an idea about near misses, picture this. You're driving on a highway. The vehicle in front of you decides to suddenly slam the brakes. You now have a few seconds to brake or get out of the way, otherwise you're going to crash. And thanks to advances in sensing technologies, we can actually detect this evasive maneuver. So I can tell you you're 3 seconds away from crashing. You are 4 seconds away from crashing. These two cars are 0.5 seconds away from crashing. So with all of our camera data, we can gather this and create a distribution. But I looked at my distribution. It's kind of weird. What does it mean to be 0 seconds away from crashing or negative? Well, you've crashed. So it really is that simple. You look at our distribution, and you can find the probability of a crash. And we haven't used any crash data. We didn't observe a single crash. We used very little data, in fact. Like, you can use like a few hours, really, and we can predict reliably the number of crashes, which is so powerful. But where exactly do we go from here? So the focus of my research is to investigate the spatial and temporal characteristics of real-time crash risk data and use it to develop various different solutions to improve road safety. So the first solution that I developed is a tool to look at your entire network, a hazardous location identification system. So decision makers can see exactly where are the most dangerous locations and the safest locations. And we also differentiate between locations that are chronically unsafe and locations that occasionally have peaks. And I propose different solutions on how to deal with these. Next, I investigated the use of real-time crash risk data as it applies to navigation. So we all use Google Maps to get from point A to point B in the safest way possible, in the fastest way possible. Mic issue there. But what if we can go from point A to point B in the safest way possible instead? And actually, with real-time crash risk data, this becomes possible. And we've actually upgraded our methodology to not only include vehicle-vehicle near misses, but also vehicle-cyclist near misses. So we're able to give you the safest route, which is very useful since cyclists tend to be risk-averse while making navigation decisions. And lastly, we looked at different ways that we can actually improve our intersections. So we found that in some cases, by extending a signal green, for example, you can actually prevent some rear-end collisions from happening. So we applied an AI algorithm to actually optimize our entire corridor specifically for safety, achieving a 24% reduction in crashes. So we no longer have to wait for a statistically significant number of crashes to occur. We can simply act now. Thank you very much.